of C1 of CMC. Basically, the C1 has three questions. A. Find all integers values of A, such as the equation x squared plus ax plus 1 is equal to 0 does not have any real solutions in x. B. Find all pairs of integers a, b, such as both equation x squared plus ax plus b is equal to a0 and x squared plus bx plus a is equal to 0 has no real solution to x. C. How many ordered pair of positive integers satisfying a is less than or equal to 8 and b is less than or equal to 8 are there, such that each of the equations x squared plus ax plus b is equal to 0 and x squared plus bx plus a is equal to 0 has two unique real solutions to x. Okay, let's start with the problem A. Let's see that in A, we want to see that in order for ax squared plus ax plus 1 is equal to 0, the discriminant, aka which is the square root of b squared minus 4ac. Remember, this is discriminant, not discriminate. It's discriminant. Must be undefined, aka which is the b squared minus 4ac is less or equal to 0. You may be curious, like why? Because the equation of the formula of the quadratic equation is negative b plus or minus square root b squared minus 4ac divided by 2a. So in this case, if negative b squared minus 4a does not have the real solution, subsequently the two roots are also going to have like unreal, what's that called, imaginary roots. So inspection on the quadratic equation in A, we see that A is equal to 1, B is equal to A, C is equal to 1. So this is because the traditional quadratic equation is usually in the form of ax squared plus bx plus c. In this case, we can see that x squared is the ax squared part, so A is equal to 1. Ax is the bx part, so B is equal to A and C is equal to 1. Hence, we plug A, B, C back to the equation and we are able to see that a squared minus 4ac less than or equal to 0. So this means that a squared minus 4 is less than 0 and hence a squared is less than 4. So this means that the absolute value of a is less than or equal to 2. Right? So this means that a can be only 0, 1, and negative 1, since the problem states explicitly that a is a integer. Now let's talk about C1b. Using the same method, using the same method, the discriminant must be undefined, hence it's b squared minus 4ac is less than or 0. Expecting on both equations, we are able to see that for the first equation, we are able to derive a squared is less than 4b, and for the second equation, we are able to derive b squared is less than 4a. This is because that we have used the same way as before, where we can plug in the value of BAC inside the discriminant. For example, in the first one, we have A is equal to 1, B is equal to A, C is equal to B. And for the second one, we have A is equal to 1, B is equal to B, C is equal to A. So in this case, we plug it back to B squared minus 4AC and we are able to get the final result. We can then test the positivity of A and B on whether the equation 1 or 2 would, first of all, exist. At a positive A and positive B, the equation would exist. Why? For example, if you go, the equation might be exist. For example, if you test like equation 1, right? A squared, you set A as a very high value, 1000, 10 trillion, and B as A as a very small value, like 1, and B as a very large value, 1 trillion, 2 trillion, it works. And it works conversely for equation 2. And let's say for equation 1, a positive b and a negative, a positive b and a negative a would also exist. Because negative square is positive, right? So in this case, we can set negative 1 and b as 1000 and it work. However, the something that I would say is that at negative b and positive a, the equation would be impossible. Why? Because if you go back, if you go back to here, go back to here, Just give me a sec. Negative b and positive a. Because the left side must be positive and the right side of negative, and it is impossible for positive number to be smaller than negative number. Hence, let's go back. Hence, a positive a and a negative b should not be exist, while a negative a and negative b also does not exist because the left side is negative square is positive, and the right side is positive negative. So positive cannot be greater than positive cannot be smaller than negative. Hence, aka just give me a sec. We're able to see that this is going to be the results for equation one. Test results for equation one. Let's now test the same for test results for equation two. Know that at a positive a and positive b, the equation definitely exists. But for the negative a and positive b, it won't. Why? This is because that uh, b, in this case, b squared is a positive number because positive square is positive. And 4a, 4 times a negative number is definitely a negative. So since the positive number, cannot be smaller than a negative number, it is like a negative a and a positive b will not a negative a and positive b will not exist. Using the same way, you are able to derive that this does not exist. And now let's see whether this exists. Positive a and negative b. This will definitely exist at some occasions because negative square is positive, right? Negative square is positive. And now the right side, 4 times the positive number is definitely positive. So it is possible for positive number to be smaller than positive number. So therefore, you can see from the table 1 that the equation 1 would only work when a is positive and b is positive. And in equation 2, you can see that the equation would only work when a is positive and b can be both positive and negative. So combine this and this. We're able to see that the only grid that touches both of them, is positive a and positive d. Like only positive a and positive b would exist in both equation 1 and equation 2. Okay. Given that condition, we can simplify equation 1. A squared minus 4b less than 4b. What we can do is that we can square both sides. So we get a to the power of 4 less than or equal to less than 16b squared. And then we divide both sides by 16. We're able to get a to the power of 4 divided by 16 less than b squared. We can plug this new inequality back to the equation 2, which is stated b squared less than 4a. Since that a4 divided by 16 is less than b squared, the equation can be combined into a4 divided by 16 less than b squared minus less than 4a, which hence is equal to this. Manually testing a different value, we're able to see that this equation above would work and only work if a is equal to 1, 2, 3. So in this case, we put the value back into the b squared, this equation we're able to see. We're able to see that. Let's first plug in the equation, let's first plug in b is equal to 1. We can see that b is at, let's first plug in a is equal to 1. Let's say that 4 times 1 is 4, right? So this means that the b squared is less than 4. Hence, the only possible value left for b is equal to 1. B is equal to 1. Why not b is equal to negative 1? Because we stated before that the both equations, in order to make both b squared less than 4a and a squared less than 4b work, the both equations has to be like both a and b has to be positive. So in this case, the only possible viable solution left for us is b is equal to 1. Okay, b is equal to 1. And for the second thing, when a is equal to 2, a is equal to 2, since we can plug in a, so it's b squared less than 8. In this case, we can find out the b. At b is equal to 1, 1 less than 8. At b is equal to 2, 4 less than 8. At b is equal to 3, 9 larger than 8. So it doesn't work. Therefore, the only possible values for b is 1, 2. Using the same way, b squared less than 4 times 3, 12. B squared less than 12, right? So it's b can be 1, 2, 3. 4 squared is 16. 16 larger than 12. It doesn't work. So from this, we're able to see that we're able to come up with 6 candidate. Remember, it's only candidate dots. 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, 3, 3. Back to a squared is less than 4b. We find that at b is equal to 1, a is equal to 1. At b is equal to 2, a is equal to 1, 2. At b is equal to 3, a is equal to 1, 3. Basically, just use the same idea as before. So for example, let's plug in b is equal to 1. So this means that a squared is less than 4. In this case, a can only be 1, and it cannot be 2 as 2 squared is equal to 4 instead of less than 4. So in this case, you can see from this you are able to get 6 dots. So basically what we need to do is that we would only need to find the dots that works in both first equation and the second equation, aka the dots that exist in the first 6 dots, in both the first 6 dots and the last 6 dots. So since 2, 1, 3, 1, 3, 2 does not fulfill with this equation, sorry, 2, 1, 3, 1, 4, 3, 2 does not exist in does not work in this equation, it is eliminated. A squared minus 4b, right? A squared less than 4b. So this leaves us with the only possible values of 1, 1, 2, 2, and 3, 3, which hence this is going to be the answer of the equation. Let's now start talking about C. Using the same way from the B, we are able to first identify a common thing that both equations fulfilling the condition of having two distinct roots. We have to set a squared minus 4b is larger than 0 and b squared minus 4a is larger than 0. So this means that a squared 4b and b squared 4a. Basically, just use the same way I did in equation 1 and equation 2. Okay, you just use the same way I did. Since we see that the problem states explicitly that a squared is less than 8 and b squared is less than 8, just give me a sec. Yes, the problem stated explicitly from here. Positive integrals satisfy a less than or equal to a and b less than or equal to a. So let's go back. We could use brute force to help us assist the final answer. Basically, the brute force will just test each value one by one. 1, 1, 2, 2, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Because there's only 64 possible total choices. So we can just test each one to see whether which one works. Now let's see. So let's see this graph. Let's see this graph. Let's see this graph. Let's see this graph. From this graph, you're able to see that x is the equation that does not fit with equation 1, and z is the equation that is the case that does not fit equation 2, and y is the equation that fits both. Recall that the equation 1 is going to be, what's the equation 1? I forgot. Equation 1 is going to be let me see. Equation 1 is going to be the a square is larger than 4b, while the equation 2 is going to be the b square is larger than 4a. We are able to see some rules here. Just give me a sec. We're able to see some rules here. So let's go back and we find out that equation 1 is a squared plus 4b and equation 2 is b squared plus 4a. So in this case, we're able to obtain that. We're able to obtain this graph. This graph is left is 1. Left refers to value of a and right refers to the value of b. So in this case, equation 1 is 1, 1, right? 1, 1 is, let's for example, make an example of 1, 1. 1, 1 is the case that it does not fulfill with equation A because if we plug it back, 1, left side, 1 square, 1. Right side, 4 times 1, 4. 1 is not larger than 4, so it does not fit with equation 1. Let's test the second, let's test another one too. This is an example of y, 2, 3. So a is equal to 3, b is equal to 2. A is equal to 3. Okay, A is equal to 3. So B is equal to 2. Left side, 2 squared is 4. Right side, 4 times 3 is 12. So it doesn't work. It doesn't work. It doesn't work. Either. Why? Sorry, it doesn't. It doesn't work either. So I mean, it should be Z. Let's go back and see the equation that works here should be this one. Those things are the ones that work. Those ones. So for example, let's test a left side is A and right side is sorry, left is B A, right is B. So 5 5. In equation 1, 5 squared larger than 4 times 5 is 25 larger than 20. Right side is 5 larger than 5 squared larger than 4 times 5. So it's 25 larger than 20 also. So in this case, we are able to find that this one works. And let's test this one again. A is equal to 6, B is equal to 5. So A is equal to 6 squared, B is equal to 4 times 5, so 36 larger than 20. Other hand is 5 squared, 25 larger than 4A, so it's 25 larger than 24. So this equation also works either. So from this way, we are able to obtain 11 different coordinates, which are going to be, let me see, 5, 5, uh, 6, 5, 6, 6, 6, 7, 8, 6, 7, 8, 6, 8, 7, 6, 7, 7, 7, 8, 8, 6, 8, 7, 8, 8, which is 11 coordinates in total. And those coordinates, aka the AB value, are going to be the values that are going to be the answers for C. That fulfills the condition that both the equation, let me see, x squared plus ax plus b is equal to 0, and x squared plus bx is plus a is equal to 0 has two unique real solutions in x. Here we come to the end of our lesson and I hope you have learned a lot. See you next week. Bye bye.